Today I'm going to take a look at the strategy pattern and how you can implement it in Python. And I won't just look at the classic object-oriented version of it, I'll also introduce a couple of varieties built on more recent features in the Python language, including a really cool functional approach to the strategy. While I'm writing the code, I'll be using Tab9, an AI code completion assistant that directly integrates into your IDE. They're also the sponsor of this video. Tab9 is an AI assistant that provides smart code completion in your IDE. It supports over 30 languages, including Python, in 15 IDEs, including VS Code and PyCharm. Tab9 offers both a local model and a cloud model. You can choose to run Tab9 locally only, and your code never leaves your machine. This also means you can use it to work offline while ensuring maximum security and privacy. Tab9 recently launched Tab9 for Teams, which will learn your team's projects, preferences and patterns, suggesting even better code completions for you and your team members. You can get Tab9 Basic as a free extension to your IDE of choice. If you're a student, you can get Tab9 Pro for free. For more information, go to tab9.com/students. Or, if you're not a student, you can use coupon code ARJAN to get a discount off the Pro plan. The links are in the description of this video. Today's example is an example that I had in one of my earlier videos as well. It's a simple support ticket handling example. There's a main function that creates a customer support instance. I'll show you in a minute what that is exactly. Then we're registering a few tickets, and then I'm calling a process tickets method that gets a ticket processing strategy. In this case, it's first in, first out. This relies on customer support and support tickets. Support ticket is a data class that's in this file. It's under the support folder, so you can also see that that's why I'm importing it like this here. And in this class, it just has a few fields. It has a customer, it has an issue, and it has an ID. And what I'm doing here is that the ID is a field that is not initialized when you create an instance of support ticket. You can also see this in the main function. So I'm creating the support ticket here, but I'm not providing the ID. The ID is generated because in the post_init method, that's the method that's called after the object, after the instance has been created, I'm calling a generate ID function and then storing that generated ID in the ID field. And this is a very simple helper function that just uses random uppercase characters and then generates a string from that. Support ticket also has a process function that does nothing at the moment. It just prints out the ID, customer and the issue. And customer support, which is the other class that the example is using, it simply maintains a list of tickets. That's what you see here. It has an add ticket method, and it has a process ticket method that, given this processing strategy, processes the tickets in a different way. And the way I'm doing this here is using an if-else statement. That depending on the strategy, I'm ordering the tickets differently and then processing them. Once I'm done processing these tickets, I clear the tickets list. And that's basically all there is to it. Let's run this code and see what it does. Let me just make this a bit larger. So here you see it's just processing these tickets that are just added in the code here. And this is using first in, first out. I can change this to another strategy and then we're going to get a different result. So now it's first in, last out, and that means that this one that I defined first is going to be processed last. And this is a typical example of where the strategy pattern can help. The strategy pattern allows you to inject behavior into an application without the code knowing exactly what the behavior does. Here's a class diagram. The pattern relies on an interface, basically the signature of the strategy function, to break up an application and reduce coupling. The idea is that the interface specifies a method, and then you create classes that implement that interface, and you can create instances of those classes and inject them into the different parts of your application. And then those parts of your program will call that method without knowing what the method is actually doing. It only knows the signature of the method that it calls. So let's look at the classic strategy pattern first and then dive into a few really cool variations. The classic strategy pattern uses classes, abstract classes and inheritance to create the effect of being able to insert different strategies. And that's a very typical classical object-oriented way of approaching things. Later on, I'll show you a few other ways to do this. But in order to get started, I just want to build the classic thing, and then we're going to modify it later and hopefully also improve it a little bit. So what we're going to do in this case, in order to remove this if-else statement here and use a strategy pattern, is to create for each of these different processing strategies, create a different strategy subclass. And actually, it's not really a processing strategy, it's more an ordering strategy. So what I'm going to do is first I'll import the ABC abstract base class and abstract method. There we go. And I'm going to create a class called ticket ordering strategy. So that's an abstract base class, and that also has one abstract method that's called create ordering. And that gets a list of support tickets, and that is also going to return a list of support tickets. There we go. That's our basic ticket ordering strategy class. The only thing it does is create an ordered list. So now what we can do is create subclasses of this abstract class. So let's say I'm going to create a first in, first out ordering strategy. And that's a subclass of the ticket ordering strategy. And that will have a create ordering method that has the same signature as the one in the abstract base class. And what this is going to do, first in, first out, is just going to return a copy of the tickets list. We can create similar classes for each of the different ordering strategies that we'd like to have. So let's also create the first in, last out one. And what this is going to return is a reverse of the tickets. So I'm just going to call the reversed function on the tickets list and then turning that again into a list, because reversed actually is a generator. And finally, I'm going to create the random ordering strategy, which of course also inherits from ticket ordering strategy. That also has a create ordering method, returns a list. And what this does is this returns a sample of the list of tickets of the length of the tickets list. So this is then going to return a random ordering of the current list of tickets that we have. So these are our strategies. Then in the customer support class, we no longer provide this strategy as a string, but what we're going to do is provide it as an instance of ticket ordering strategy. Then the first thing we're going to do is create the ordered list. Let's call that ticket list. And then we're using the processing strategy and we're calling create ordering with the tickets that we currently have. So that's our ticket list. And then the rest of the code, I'm going to work with ticket list instead of the list of tickets. That's the part of the instance. So here I'm going to write ticket list. If there are no tickets, we don't do anything. And then this if-else statement we can basically replace by a very simple piece of code. So let me just remove this and I'll add a simple part that goes through the list of tickets. There we go. So for each ticket, we're going to process it like so. So now process tickets no longer relies on any particular type of processing strategy. We could create new ones and then use those instead. Now, obviously in the main part, I still need to update this because here I have a process tickets function that still passes a string. I need to replace this by passing a particular ticket processing strategy. So for example, what I could do is pass here a first in, last out ordering strategy, like so. It automatically imported that, so that's great. Let's run this and see that this still works. So yes, this still works. And what's nice now, because we have the strategy pattern, is that we can create our own custom strategies and then use those instead without having to change anything in the customer support class. For example, I will write it here so you can see what the difference is. I could create a black hole strategy. And that's a ticket ordering strategy that's also automatically imported, which is nice. And this needs a create ordering method, just like the other strategies. And that's going to get a list of tickets. And that's also going to return a list of support tickets. And the black hole strategy is very simple. That just returns the empty list. So let me replace this. So now I can just write here black hole strategy. And let's run the example. And you see there are now no tickets to process, which is great. And now this import here is no longer needed. There we go. So the nice thing is we can create new strategies like this one. And I didn't have to change anything in the customer support class. And that's the power of the classic strategy pattern. And note the dependencies here. So we're relying on customer support because we create this instance of this class. We're relying on support ticket because we're creating tickets. And we rely on the ticket ordering strategy because that's a superclass of the black hole strategy. Now, instead of abstract base classes and abstract methods, you could also use protocol classes. So let's see how that works and what the effect is of doing that. So in order to change this to using protocols, I'm going back into the app.py file. So we have here the ticket ordering strategy, which is currently an abstract base class. What I'm going to do instead is turn this into a protocol. And that's part of the typing library. And we don't need this abstract method thing anymore because we're not going to use inheritance. In this case, we're going to use the protocol mechanism. So I'll remove this here because that's not needed anymore. And because this is a protocol, we now don't need to create these subclasses, but we can just directly use these classes here, and then Python's typing system, Python's doc typing system is going to help us do this in a nice way. So let's delete the inheritance here, and I'm going to do the same thing here and also the same thing here. So these classes no longer directly inherit from ticket ordering strategy. I don't need to change anything in the customer support class because it's simply expecting a processing strategy of this type. So that's all there is to it. And now in the main part, because ticket ordering strategy is a protocol, I don't need to inherit here either. So I can just write the black hole strategy class like so. And that means I can also remove this dependency here. So you see what the effect is of using protocols is that it basically removed one dependency, one extra import here, because the doc typing system is solving that for us. We don't need to explicitly inherit from this anymore. I've discussed protocols before. Of course, there are some disadvantages to using that. For example, I have to make sure that this create ordering function actually matches what is expected in the protocol. And if I make a mistake, the typing system might not always pick that up automatically. So with abstract base classes, this is a bit more strict. But still, it's a nice alternative that you could use for this. So let's run this one more time, and we still have no tickets to process. So that's protocols. Another thing you can do is rely on the dunder methods to simplify the code even more. Let's go back into this app.py file. So as you can see, actually, the name of this create ordering method doesn't really matter that much because it's already kind of defined by the name of the class. So we're kind of doing a double job here. So what you could do is, instead of having a create ordering method, it's simply having a call dunder method, and then you can just call the object that you have and you're done. So that even shortens the code a bit more. So let's change this to being a call dunder method, like so. And then of course I also need to do that here and here and here. Oh, wait, and here. And then in the customer support class, I can simply use processing strategy like this. I'm kind of using it like a function. It's a callable, basically. So this is even shorter. And let me go here to the main file, because now obviously the black hole strategy also needs to be updated. There we go. And let's run this again to check that this is still working. Yeah, it is. And just to make sure, I also want to try one of these other classes. Let's say we're going to use the random ordering strategy. Just want to make sure that this still works correctly as well. So now we're getting our tickets back again in a random order. A couple of weeks ago, I did a video about the factory pattern where I used a similar approach, also using the call dunder method. If you want to watch that video, I'll put a link here in the top. So those are a few varieties of the strategy pattern that still kind of rely on object-oriented programming using classes. In essence, that's not really needed, because all that a strategy is a function, right? So why not simply use functions instead of classes to simplify things even more? When the strategy pattern was conceived, object-oriented programming languages were really strictly object-oriented. Everything is an object. Functions did not exist. There were only classes with methods. So there was no way to do it, actually. But of course, Python has a lot of modern features. It blends aspects of functional programming with object-oriented programming. So there are other ways to achieve the same thing, but better, and not having to rely on these classes, but doing things in a more simple way. So instead of having classes, either with protocols and inheritance or with call dunder methods, you could also simply just define a bunch of functions. And then those functions are going to be the different strategies that you use. So I'm going into app.py and I'm going to change these classes into functions. Now what we do want to have is some way of defining what a function should look like in order to be used. And that's basically the role that ticket ordering strategy has in this case, because that's the protocol that you should follow. But we could actually simply define a type alias and then use that type alias. So I'll remove this class here. And I'm going to say that ticket ordering strategy is a callable. And callable is part of the typing library, so I'll just import it here. So this is a callable, and its input is going to be a list of support tickets, and the result is also going to be a list of support tickets. So now we have our ticket ordering strategy. And what's interesting is that now actually the program still works and there are no typing issues. So I can still run this. And this is all working fine, even though I removed the protocol class and replaced it by a simple type. And that's because the distinction between classes, objects, and functions is not as big as you might think. They're basically all callables. And that means that if I specify a type callable, like so, I could use an object of a class with the call dunder method, I could use a function. Those things would work both just fine. So now, for example, what you can do is create another function here called, let's say, first in, first out strategy. And that's going to get a list of tickets, like so. And that is also going to return a list of support tickets. And let me just remove this like this. So now we have a function that does basically the same thing as the class that we had before. And I can do the same thing for the first in, last out one. And then let me just remove this. There we go. So now we have a first in, last out strategy. And if I go back to the main part of my code, I can just put in here the one of these functions, and then process tickets is going to use one of the functions. There we go. First in, first out. And when I run this, it uses that particular strategy. So our type is a callable type. And it doesn't matter whether I'm using a function, which is a callable, or whether I'm using a class with a dunder method, because an instance of that class is also going to be a callable. So for example, I can now still use here the random ordering strategy, and it will all just work fine, like so. Yeah, so this also works. There's one issue with using functions though, even though there's a way around that as well. And I want to show you what I mean by that. Let's say you want to have a strategy where you want to set some parameters of the strategy. For example, this random ordering strategy, well, maybe you want to set a seed value before you process the tickets using this strategy. If you have a class like this, you would add an instance variable that would contain the seed value, and then you'd have an initializer to set that. So let's add that here. So I'm going to turn random ordering strategy into a data class, and I'm going to provide it with one seed value, which let's say is an optional, because we don't always need a seed value. So we initialize it with none. And then in the create ordering, what I'm going to do is set the seed here, random.seed, and then self.seed. So now we're seeding the random number generator with a particular value. I'm not calling it with that particular value, so every time I run this, I'm going to get a different result. But I could now pass it a seed value, like so. Let's say I give it a seed of 1. And now you see every time I run this, I'm going to get the same result because, well, the seed is the same. The problem occurs if I want to turn this random ordering strategy into a regular function, because where do I set the seed? I don't have an initializer anymore. And I can't pass it as an extra parameter to the strategy function, because the function is supposed to follow this callable structure, which only expects a list of support tickets as an input. I could make this more generic by adding a ... or something, or adding arguments extra, which I don't really like that much, because then basically customer support needs to know about that stuff. I did another video about that a while ago. I'll put a link here in the top if you want to watch that. But basically that's the trade-off. If you use these simple functions, then passing along parameters is going to be a bit more complicated. You can still do it though, and that's by using closures. So let's create a new function called random strategy creator. And this takes the seed that by default is none, and this will return a ticket ordering strategy, which is a callable. So this will return a function. I'm going to define this function inside the random strategy creator function. And this is the actual function that follows the ticket ordering strategy type. And there we're basically calling random.seed with the seed, and then returning the sample of the tickets and the length of the tickets, like so. And then we're going to return the random strategy. And now when I want to use this function, I'm going to go in here in the process ticket strategy, and then I'm going to call this random strategy creator, and that gets the seed. It works exactly the same way that a class would work. And now you see that I can simply run this. I'm going to get the same result. If I remove this seed, then we're going to get the different behavior every time we run the program. This is called a closure because basically we have variables like seed that are available inside the function, and the function is returned. But if you look at the main program, actually this function is called and then is passed as a parameter. And that means that this function, or the closure, keeps track of the internal variables like seed. And that allows you to do a thing kind of similar to how it also works with classes, where you create the instance that contains parameters or instance variables that contains data. And then you have methods that can do something with that data. And here it's basically the same thing. So we also have a kind of a method, but it's called a closure, that uses the seed parameter. And you could even define other local variables here. Like, for example, I could say I have a use seed, something like this, right? And then I could write here if use seed, and then we're going to set the seed, something like this. And then you could even pass this as second parameter here if you wanted to. And these variables you define here inside this function are actually a little bit more protected than they would be in a class. If you have a class with instance variables, you can simply access them by writing object.instance variable. And here it's a bit more complicated. They're not true private variables, you can still access them, but what you need to do is use a closure dunder method to do it. So when you do it, it kind of is clear that you're not supposed to do this. So as you saw in the example, the distinction between functions, classes, and objects is not as clear as you'd think. In fact, classes, objects with the call dunder method, and functions are all examples of callables. The syntax is just slightly different, and each of them offer different benefits. The result is that for most of these classic object-oriented patterns, you can probably mix classes, functions, and objects differently to get variations of the pattern, like I did in the example code. And in the end, it's also a matter of taste. Do you prefer simple functions, classes, objects? It's kind of up to you. And in software design, it's much more important to apply the design principles, and the patterns and the variations of the patterns follow from that. For example, the strategy helps to reduce coupling. So the goal is to reduce coupling, not so much to use specifically the strategy pattern, because any of the variations that I discussed today also reduce coupling, and maybe even shorter and easier to implement than the classic object-oriented strategy pattern. So I hope you enjoyed this. If you did, give this video a like. Consider subscribing to my channel if you want to watch more of my content. Don't forget to check out tab 9, the sponsor of this video. Links are in the description below. Thanks for watching, take care, and see you next week.